We're looking at examples 1 and 2 in Unit 5, Section 4, which is about trapezoids and midpoints. You've already learned how to use those formulas. And so now our goal is to try to apply that. So we see this problem. Water is flowing into a tank at a rate of R of T, where R of T is measured in gallons per minute and T is measured in minutes. This is a rate and a time. The tank contains 15 gallons of water at time 0. Values for R of T are given in the table. Using a trapezoidal sum with 3 intervals indicated by the table, what's the approximate number of gallons of water in the tank at time 9? Well, the first thing we want to remember is that the tank has 15 gallons to begin with. Okay, so we know we need to start with 15. And then we need to add on an approximation for the area under the curve from 0 to 9 minutes, R of T dt. And R of T, they have told us that we want to approximate this R of T here. Guys, I'm struggling, sorry. That we want to approximate this R of T by using a trapezoidal sum with 3 intervals indicated by our table. So I've drawn a little picture of that over here to kind of give you an idea of what we were starting with. So I think if you see the picture, you can see we have 4 points. And so our 3 trapezoids are going to be the 3 that are connected by each of the endpoints. So we've got a trapezoid here. I've drawn in green, and then I'll draw this one in blue. And I've got this one that I'll draw in red. Okay, so we've got 3 there, and they're each going to have different dimensions. So we're going to start with our 15, and then we're going to approximate that integral with our trapezoid. So our trapezoid formula is 1/2 times the height of the trapezoid, which remember is going to be this distance, times the sum of the bases, which are going to be, the bases will be these sides here. So for my first trapezoid, I'm going to do 1/2 times the height, which in this case is 4. That's for my green one. Times the sum of my bases. So this first base has a height of 9, and my second base has a height of 6. So that's my first trapezoid, my green one. My second trapezoid is this blue guy right here. And so I'm going to add on 1/2 the height of that trapezoid, which is 3. And let's see. Now my bases are going to change. Now it's going to be B1 and B2 here. And so we're looking at 6 plus 4, looks like. And then last, I've got my red trapezoid. His height is going to be this distance here, which is just 3. The height does not have to be the same every time. And then B1 for this one would be 7, and B2 would be 9. And so adding all of that together, I'm going to get 52 for my integral, which I'm going to add to my 15. And that's going to give me an answer of 67. Which is C. Okay, scrolling down, let's have a look at number 2. Number 2 is asking us to use a midpoint Riemann sum. And so what I think the hard part about midpoints is that you have so many points, but you're only looking for, in this case, 3 subintervals. So 3, we're looking to find M3. We're going to approximate this using M3. So how would we go about doing that? Well, we need to draw 3 rectangles. So I think we can agree that if we're going from 0 to 6, that one of my rectangles is going to go from 0 to 2, and then my next one is going to go from 2 to 4, and then my third one's going to go from 4 to 6. So let's try to draw those guys first, okay? My rectangle is going to have a width of 2, And its height is not going to be determined by the right or the left. It's going to be determined by the midpoint, which for the red rectangle is 3.5. We're not going to use the 4 and we're not going to use the 2. We're going to use the 3.5. Okay, my blue rectangle is going to go from 2 to 4, but his height is not going to be determined by the 2 or the 1.7. It's going to be determined by that middle value, which is 0.8. And then my final rectangle has a width of 2 once again. And that rectangle is not going to have its height determined by 1.7 or by 7, but by this middle point, 5.8. So if I want to calculate M3, then I need to do this first rectangle, which has a width of 2 and a height of 3.5. My second rectangle, which has a width of 2 and a height of 0.8. And my third rectangle, which has a width of 2 and a height of 5.8. And so adding all of that together, multiplying out and adding together, I'm going to get 20.2 for my approximation from the integral from 0 to 6.